Okay, question number 6. We can see, looking at this, that in the new denominator, x times x times x is going to give you an x cubed term. So it's not top heavy, so I can go straight into dividing into partial fractions. So I can rewrite the expression in the integral as a over x plus b over x minus 2 plus c over x minus 1 here. Now, cross multiplying, I've got to make the denominator in the same on both sides. So what have I got to times the x by in this term to get x times x minus 2 times x minus 1? Well, this, x minus 2 times x minus 1. So times a by that, b by this, and c by this. And then they're all got the same denominator. So now I can equate numerators, and I can say that the numerator on the left-hand side equals the numerator on the right-hand side here. Now I can expand, collect like terms involving x squared, x, and the numbers together, and then I can equate coefficients. So see if you can carry on from here. Solution follows. So taking this expression, first of all expand out the right-hand side, expanding x minus 2 times x minus 1, I get x squared minus 2x, minus another x is minus 3x, and then minus 2 times minus 1 gives plus 2. So this is this term here. Then expanding bx times x to get the bx squared, bx times minus 1 gives minus bx, cx squared minus 2cx. Multiplying out this bracket here, I get a times x squared minus 3ax plus 2a. And now what I do is collect together terms involving x squared, the x, and the 2a. If you look at this one, the x squared term, we've got ax squared plus bx squared plus cx squared, gives a plus b plus cx squared. This one's one to be careful of. Minus 3ax minus bx minus 2cx. So it's minus 3a x, but minus outside the bracket means it's plus b inside, plus 2c inside. Just satisfy yourself that works. If I expand out this bracket here, I'll get minus 3a minus b minus 2c, which is what I want. So if I've got a minus outside the bracket here, they all become plus inside, and then finally plus 2a at the end. So algebraically, just be careful of that little step here. Now, once you've got to here, we can equate coefficients and solve to find the numbers a, b, and c. So I can equate the coefficients of x squared on the left-hand side with the right-hand side, and so on. See if you can continue from there and solve those three equations you're going to get to find a and b and c. Solution follows. So the first equation I can write down is that a plus b plus c equals 1. These are the coefficients for x squared. Minus 3a plus b plus 2c equals minus 3. These are the coefficients of x. And if it's negative both sides, I can multiply both sides by minus 1 to get 3a plus b plus 2c equals 3. So that's the second equation. And the last one, just the numbers, 2a equals 6. So solving those from 3, directly I can say that a equals 3. If I take away equation 2, take away equation 1, or take 1 from equation 2, I'm going to get 3a minus a leaves me 2a. B minus b is gone, that's eliminated. 2c minus c equals c. 3 minus 1 here equals 2. So I've got 2a plus c equals 2, but I know that a equals 3, so 6 plus c equals 2, so c equals minus 4. Now finally I know a and c, so I can substitute those values back into equation 1 to find out what b is. So I've got a, b and c. Now I can put these values back into the expression for partial fractions and solve the integral. So see if you can do that. The solution follows. So here's the original expression in partial fraction form. So the integral becomes this. And I can integrate each one in turn, and they are standard integrals. The integral of 3 over x is 3 log x, 2 over x minus 2 is 2 log x minus 2, and so on. And then I put my numbers in, see if you can finish this now. Limit 4 and then limit 3, and you should get the answer 0.6275.